Hi, this is Alvin Alexander, author of the Scala Cookbook, and this is a video version of recipe 20.6 using Spark SQL queries against multiple files. I could demonstrate this recipe at the command line with Spark, but to make things more interesting, I'm going to demonstrate it with the Databricks platform. And the problem statement for this recipe is that you'd like to see how to use real SQL queries against a data set, including the use of joins on multiple files. So let's jump into the code. So in this recipe, I use the movielens.org data set, which is very cool, has over 62,000 movies in it. And I use these three files in the recipe: movies, ratings, and tags, which are all CSV files. And it takes a while to upload those because they're pretty large. So I've already uploaded those, and I can show that with this command here in this cell. So I'm doing a file system command and ls command in this directory. So I'll go ahead and run that. And then what you can see amongst the results is that I have the movie CSV file here, ratings, and tags. So those are all uploaded, and you can see the ratings file is quite large. And the next thing I show in the recipe is a little bit of the top of each file using the head command. So on Databricks, you can do a head command using, you start off with %fs, which says it's a file system command. And then this is the beginning of the movie CSV file. So the keys here are: the first row includes these header names, so movie ID, title, and genres. And then when we look at the data, you can see the movie ID is an integer or a long. The second column is the title, and the titles are interesting because they have the year embedded in them within parentheses. And then the genres column is also interesting because it has multiple genres on each row separated by a pipe character. So again, that makes the data more interesting to work with as far as queries go. So that's the movies file. This is the ratings file. Let's go ahead and run that one. So again, using the head command, you can see user ID in the first column, movie ID in the second column, and that's going to be what we join all these tables on. Then the rating is the one that we're really interested in this file. So you can see the rating in this column and then the timestamp. And then finally, the tags file is the third one. And you can see again here, user ID, movie ID, tag. So we'll be joining on the movie ID, and then we're mostly interested in the tag here. Next thing I do in the recipe is I read the three files into data frames. So what I've done here is what I'm going to do here is read the data into a movies data frame, a ratings data frame, and then a tags data frame. And the way I do it is the same for each one. So I'll just kind of cover the first one here. We start with the Spark variable we call read on it. And then I'm going to pass in two options. The first one here says that the header is true, which means that this file has a header row. And since all three files have a header row, this first one here, I'll just show that one. So that says I have a header row. The next one says infer the schema from the data, and I set that to true. So that tells Spark, go ahead and infer the data types. As you read the file, go ahead and set the data type yourself. So I'm not setting a structure on these files like I did in the previous recipe. I'm just saying, hey, Spark, go ahead and figure that out. And then the last line is I specify that I'm reading a CSV file, and I give the full path to the file. So this one is movies.csv, then ratings.csv, and tags.csv. So it's going to take a little while to do those. I'll start those up and run that. Okay, so you can see from this field down here that took a little over 56 seconds to read in those three files. And the important thing here is you can see that it inferred on the movies table that movie ID is an integer, title and genres or string. And then also similarly on the ratings file, user ID and movie ID are integers, rating is a double, timestamp is an integer. And then on the tags file, similar results: user ID, movie ID are integers, tag is a string, and timestamp is a, oh, that's interesting. Timestamp is a string on this one. It's an integer over here. I'm not using a timestamp, so I didn't even notice that until just now. And the next thing we do is, because we want to start working with SQL, the next thing we do is we're going to convert these into views. And we do that with this method called create or replace temp view. So what this does is it creates, these three lines are going to create three different views. One is called movies, the other one's called ratings, and the other is called tags. And what this does is it lets us treat these names in SQL queries. So let me just run that, then I can explain what I mean. That was very quick, 0.26 seconds. So key here is I name these movies, ratings, and tags. And what that does is allows me to use those names in my SQL queries down here. So you can see I have movies and ratings here, and then I'll use tags a little bit later. And so what I'm going to do in this first query here is I just want to show all movies that are rated 5.0, have a rating of exactly equal to 5.0. So I do that by selecting the distinct title from movies and ratings, so I do a join in these two rows. I do a join on the movies and ratings tables based on that movie ID. And then I say wherever the rating is 5.0 and then order by title. And then, so that's a query, which is just a multi-line string. Then I pass that query into spark.sql, and then I call show, and I say, just show me the first 20 rows. And false here just means that you want to print the full width of the data. So if you don't include false, it'll truncate your column width, and I generally don't like that. So I almost always put false here so I can see the full column width. So I'll go ahead and run that one. Okay, so that query just came back, and you can see down here at the bottom of the screen, it took a little over 32 seconds to run. And an interesting thing that this shows, and you run into a lot with data analytics, is that there's a lot of extra stuff in the data that you're going to have to account for. So here, this great performance is cat begins with triple quotes here, and then it has 2 quotes here and another one here. And this movie has some interesting formatting, more interesting formatting here. These begin with a pound symbol and so on. So just a key here is starting to look at your data and realizing that you're going to have some issues with your data. So you're going to have to do more work. But the intent of this recipe and this is really just to show how to write SQL with Spark and then run it. So that's really the recipe you're going to see repeated here several times. We write a query, then we run it, and then we look at the data. So the next one here, I am going to find all 5-star rated comedy and romance movies. So I'm going to be selecting from, again, from movies and ratings. I join those two tables together. And here, because I know what the data looks like, I say where the genres look like anything comedy, anything romance, anything. And that's just me trying to work with the data that I have. And again, the rating is 5.0, and we're going to order by title. And so you write the query, and again, you write whatever SQL you want, you pass it into spark.sql, and then you run show to see the results. And we run that. Okay, so that ran, and it came back with these results that you see here. It took a little over 30 seconds for that query, and I ordered it by title, so that's why we see everything beginning here with numbers. So again, these were all comedy romance movies, and let me explain that. So here you can see sometimes you'll have comedy romance right next to each other, and other times you'll have comedy drama romance, and I think it's even a little different here. So you have children comedy fantasy romance, and so that's why that query looks like this. And another thing to show here is that I showed this in the previous video, but I want to repeat it here. If we take show off of there and then run this again, you'll see that it comes back immediately, and that's because this doesn't really do anything. Spark, when it calls SQL, this is basically a transformation method, and transformation methods in Spark are lazy, so nothing significant happens when we do that. So that's why we have to add show back in here. So if I were to run this again now, you'll see that it will take another 30 seconds roughly to get the data. So I meant, and show is an action method. So transformation methods don't do anything by default. They're lazy, and you have to call an action method like show and other methods to make something happen. So I'm not going to run that again, but I just wanted to explain that. Oops. Also, I wanted to explain, if you do have a copy of the cookbook, there was an error in the SQL. There was a backslash here, and that had to do with converting the book from ASCII doc into a PDF. So there was a mistake there. And there was a similar mistake right here where there was a leftover backslash. So those are 2 bugs in the Scala Cookbook that I wanted to mention. And then the next query I run is a little bit longer. And this one I want to show, what am I doing here? I'm showing all 5-star ratings for all comedy romance movies. And, oh, I got you. Okay, so I'm showing the count of 5-star ratings for each romance movie. So this, oops, I'm sorry, erase the results there. So it's kind of interesting. Here you can see all the good romance movies. But what I like about this query is it shows how many people gave each movie a 5-star rating. So here I'm joining the movies and ratings table in these two rows. Again, searching for comedy romance where the rating is 5.0. Then I group it by the title and then order by the count here. So what this will give me is you'll see a movie and then you'll see a number next to it. And that number is how many people gave this movie a 5-star rating. Okay, so that came back and it took just about 35 seconds for that. So I like this because it shows me how many people, in this case, almost 26,000 people gave Forrest Gump a 5-star rating. And for me, I've seen some of these movies, but I haven't seen, for instance, Shakespeare in Love and some of these other ones. So it's kind of a nice thing. The part I like about working with this data set is it's kind of gives me some movies suggestions for me to watch, which is really cool. So that's why I like this query, and that's why I shared this one here. And this next query is not in the cookbook, but once I started looking at the data, I became interested in the tags. So I was looking at a query that joined all 3 tables, but that's just more SQL, so you can do that. And I was just kind of interested in the tags for the matrix. So that's what I'm doing here is I select the tag. And again, this is the most common tags, and the matrix happens to have the movie ID 2571. So I'm going to run that query. So then we scroll down and we can see these are the most common tags for the matrix. So you see kind of what you expect, sci-fi, virtual reality, so on. And the interesting thing about the data here is you see Keanu Reeves is in this row here with capital K and capital R. And when you start scrolling through the data, you'll see, oh, he's also here in lowercase letters. So what that told me was I want to maybe come back and instead of running my query like that, comment that one out. And then we want to run this one. So here, I'm just going to uppercase all the tags. So I'll call that upper_tag, and then I'll group it by that. So this way here, so far I have 100 Keanu Reeves with a capital K and R, and then 5 with lowercase k and r. And now when I run this uppercase query, you should find Keanu Reeves in here with 105 uppercase. So that's just one way of trying to work with the data that you're given. In the book, I get into these explain queries, and I'm not going to cover those here because I would like to kind of do those in a separate video. So there's an explain query here and another one here that are in the book, and I can run those. And you can look at these results here, but I really don't want to get into that too much here. Like I said, I want to hopefully cover that in another video. And then the last thing I show in the cookbook is how to work with timestamp fields, because that's a pretty common thing that we do all the time. So if we look at the data up here, you'll see that the timestamp is a typical Unix-like timestamp, which is not very friendly for human beings. So then when I come back down here to the bottom, this last query shows how to select information from tags. And what I do here is I convert the timestamp in this right here to something that's going to be readable, and I name that field time. So then when I run that, you will see that this is a much more meaningful time fields for human beings. So that was the purpose of showing that at the end of this recipe. So again, this was Alvin Alexander, author of the Scala Cookbook, and this was a video version of recipe 20.6, which is titled Using Spark SQL Queries Against Multiple Files. And I hope it's helpful. Thank you.